Yes, welcome back for another tutorial of this problem here, and then we're going to go step by step to go through this one. It took me a little bit of time to make this, to solve this problem. So we have a cylinder of a radius r and the length, like you guys see in the picture. You can read the problem and you can try to solve it, but I came with a solution, and I will go through step by step with you guys. So number A, we have to find a formula that has to do with the amp, the current from the points that they are given us here. So there's a cylinder on a ramp, and there's a magnetic force or strain that is affecting the cylinder on this ramp, and there's an angle. So what we're going to do, we know that there's a density of this material that is given us. So if we read the A, they are giving us, they are asking us to find a current from this density, and there's 10 turns. So let's go with the first point, when we can resolve it later. So we know that the density equal mass divided by volume, and we know that the volume of a circle is equal pi r2 multiplied by the length or the height. Okay, and then we have, the cylinder has a force affecting him, and this force is gravitational force. So we know that mass equal multiply by the gravitational force equal the amp multiply by the length multiply by the field strength, the magnetic field strength. So going back here, we can use the currents to isolate the currents. Is going to equal mass multiplied by gravity divided by the length multiply by the field strength. So what we're going to do here, we're going to isolate the mass. So density multiply P R2 multiplied by the height equal mass. We substitute this one here, so currents equal density P R2 multiplied by the height multiplied by gravity divided by the length multiplied by the field strength, the magnetic field strength. We know the length of a magnetic field strength is equal number of turns multiplied by the diameter. Here we're going to replace the length by the number of turns multiplied by the diameter. So it's going to equal P density multiplied by PR2 multiplied by the height multiplied by gravity divided by number of turns multiplied by the diameter multiplied by the field strength. The height of the wire and the diameter of the wire is the same thing, so we're going to remove this two. And the number of turns, if you see in the picture, in the diagram, in the figure, we have 10 turns. And because the coil is affected by the magnetic field in both sides, so that's going to be multiplied by 2. So that's 20 magnetic field multiplied by the magnetic field. So this is the formula that we are going to use. In question number B, so we're just going to enter the numbers in the right spot so we can find what is the current in this cylinder. So we have a magnetic, we have the density is 2500 kilogram meter cube multiplied by P. The radius is 0.025 square multiplied by 9.8 divided 20 is multiplied by 0.25 Tesla cosine of the angle 10 degrees. And at the end, the amp is equal to 9.7 amp.